Good afternoon. Y'all hear me okay? Good? All right, perfect. For those of you who are not in Colorado, I am from Colorado. Welcome to Colorado. Hopefully you're actually able to get outside, see some of the beautiful scenery and all that stuff. As introduced, my name is David Caswell. My colleague Arnav, we're from Deloitte, and we spent a lot of time thinking about the intersection of cybersecurity and AI and all of its different flavors. And in today's talk, we particularly want to kind of drill down into some discussion about securing an AI system. So we use a kind of a moniker, if you will, like security of, from, and with, right? Of being securing an AI solution and all of the components around it in order to make sure that it can be protected from any malicious, unintended malicious use, if you will. Security from would be engagements in order to protect an organization from potential use of AI in a adversarial manner, right? AI is the attack mechanism. And then security with being the concept of using AI in order to empower the security operations activities, very much what Google's done a phenomenal job with Chronicle and all of those capabilities. This context is very much going to be focused on the security of an AI system and different ways that we've come up with in order to try to create a holistic approach for securing that solution, all of its services, and the communication that's going into and out of it so that it can do what you want it to consistently. Very quick, the overview, I'm going to talk about the high-level approach that we're taking and using in building this framework and what we take through with clients. Then we're going to do a deep dive, particularly with Vertex AI, to talk about using this, how we use this framework with Vertex AI, the controls that were resident because of it, and then we'll conclude with a specific example of some of the benefits we found from that progression. Sound good? Nice, I got head nods. This is always good. Interaction makes this much more fun for both of us, right? Okay. So what's the current AI threat landscape and the current situation going on with AI? If you're in this room or in this track, you're probably well aware of this. We are now kind of sitting up at the far right of this chart, the top right of this chart, or not quite at general AI, but we're progressing towards there with the emergence, if you will, and I believe everybody in this room is hopefully aware of generative AI and some of the capabilities that has brought. If not, I'm very curious why you're in this room. So AI has progressed for a very long time. We've been doing this since the 1957 or so, and even had thoughts on it well before that. The emergence of generative AI is creating a new landscape with both threat implications. We'll go into some of those here shortly. First off, why is this important and why are we talking about this writ large? Deloitte, we've done an estimate from a global economic impact of about $14 trillion. There's numerous other numbers out there. They're all in the trillions and a significant impact that this will have over time. Happy going into kind of a discussion of like where are we at on like the hype cycle on the use of AI versus other capabilities. The summary version I would say there is, if you think about AI, we've just figured out this new cool tool. It's really powerful, and people are really thinking about new ways of using this and embedding it into their workflows and changing their systems. I think we're very much in that engineering state, as well as, frankly, a risk-rewards trade-off perspective. Like, what is new on this thing? What is that security posture? And if we do decide to go with a generative AI model, what is that going to do to the security posture of our attack surface? Which is why we came up with the security control framework to try to help provide those controls in order to go with confidence on these types of systems as they're being moved more and more from a test to a production environment. It is occurring, of course, across all the different sectors. Again, if you're in this room, you're probably already well aware of that. Some faster and some slower than others. Particularly, I would say the government public services side is a bit slower, but that's because they're much more interested in that security first mantra versus capability first mantra that perhaps some of the commercial side is engaging with. Okay, so what are the different threats that are here? Particularly in generative AI, the threat landscape is consistently being, I would say, we know some of the threats today. There are new ones be emerging over time as we go through it. This is a quick snapshot we've done, at least of an assessment of kind of some of the top threats that we're seeing consistently coming out of different organizations. If you're not familiar with, for example, OWASP and their top 10 lists, highly worth looking into. There's also a model out there with Atlas, with MITRE Atlas, and there's another model that MIT just put out with a really good set of different types of specific threats that are occurring using generative AI as a capability. The entry point of those threats are still very much an emergent discussion point. And we'll talk a little bit about that as we get into some of the technical architectures that occur for these types of systems. Of note, and we will use it a little bit in the examples, it's things like input injection or prompt injection in a generative AI model. Much of that model, if you've ever built one of these, you're literally crafting almost the question. And that question in a human readable text format version is what's actually being input into it. The idea of a prompt injection is how can I put some other code inside of that text that is going to eventually end up into the model prompt that's then going to be fed to the model that's going to have some output. And if you can do that text in a creative way, it gets a lot of things that's very reminiscent if folks are familiar with things like a SQL injection attack, where you're doing an escape path from the intended code routine that's then going to allow it to do other activities. You can think about this, and some people, a lot of folks have, asked me questions like, well, what's different about this, this kind of security architecture and how you're thinking about it from a generative AI side? I would argue it's all the new ways we can do that, right? So if you think about prompt injection, it's a simple one. Well, what if you can change the prompt of the user query and the chatbot that you're asking? Can you put controls there? Yes. Well, what about on the back end? If that chat system is then using a control tool access that's calling an API call, that's then going to go find external data that's going to come into that. Well, what if you put the code injection there up to some change of text of that prompt that's then going to be injected in the model? The controls are not as clear inside of that space. And so that's all going to say that there are changes on these types of systems. The security community is learning as we go. So this is not like, none of this is fully baked by any organization, but there's a lot of good thought and good work going on in order to continually enhance and improve this landscape. All right, so what happens when you have a lot of threats? Well, the first thing that happens is governments decide to go wild and create a whole bunch of legislation and controls, right? And so there's a huge amount of these kind of things. A lot of good work coming out of the EU, talking about different kind of controlled landscapes and approaches on it. Also in the US side, NIST, there's been executive orders out there, basically stop everything. We need to do, for example, red teaming of artificial intelligence and artificial intelligence systems. There was just recently a large conglomeration, looking for even categorizing where AI is being used inside a model so that there's a roster register of those types of services writ large. All of this stuff goes to say is it's really complex. You got a whole new set of attack surfaces occurring, you have a whole new set of attacks that are occurring, and you have a whole new set of regulations that give varying, sometimes clear and sometimes unclear guidance on how to go secure that stuff. So it creates a very confusing environment for folks who are looking at implementing these tools of how can we implement them in a manner that we are sure that we're regulatory responsible, but also protecting that core business or mission operations that you're looking at trying to ensure while providing this capability writ large. So what can we do for that? Well, let's start actually pulling together a framework. So this is kind of the problem we set out to tackle. And our response was to make a holistic security framework that goes through and looks at all of those different attack surfaces and all those regulations. And this, frankly, a global work stream that we with our partner organizations to tie all these together in order to create a mapping that says, here's the threats, here's how they're addressed by these various regulations, here's then best practices that'll apply to that one with a risk-informed basis that then drives across the technical stack. And I'll go through that here shortly in more detail. But from a nomenclature perspective, I'm going to talk about basically capabilities, domains, capabilities, and implementations. Domains, capabilities, controls, and implementations. Domains thinking, we have 6 top-level domains that we've categorized. Those both have technical as well as things like governance, risk, kind of activities. That then flows into a set of capabilities. So where are overarching areas and how do they align with those regulation guidances? That then maps into a set of controls that then protects against the threats that are being addressed by either the capabilities or the threat attack surface. And then finally, the most importantly, the implementation that hopefully will then protect, defend that control all the way back through traceability through the stack up to the regulation and/or capability domain. Okay. And so quickly, what does that look like? This kind of becomes our meta model, our placemat, if you will, of that overarching framework. And you can think of this, starting up at the, and I'm going to do this for you so that, let's see, don't blind anybody here. Oh, nope, that's not it. Congratulations, you do not have a laser to blind anybody on this one. Okay, so on the bottom left is the infrastructure, and you can imagine this kind of going clockwise around that circle. So infrastructure being the hardware that's running these things. You can think about the supply chain potentially at that level, all the way through the data, security controls that are around to make sure that data is exactly what you wanted, is not providing either bias or threats that are going into it, which is interesting when we talk about vector databases and some of that for RAG or retrieval augmented generation systems. That goes into the model itself and what are controls in order to ensure that the model is consistent and compliant with the intended purposes, and finally into the application layer. And then on top of that, you have life cycle security controls, which are continue to grow both in mechanisms that we have in order to deliver and maintain, but also even in attack surfaces, sadly, right? And so you can think about all the work that's been done, for example, on software bill of materials. Well, what does that mean inside of an AI model? You're now talking about data provenance and data lineage and model lineage and those kind of capabilities, which may or may not be present depending on the type of solution that you're trying to implement here. And finally, the six of those domains is the governance, risk, and compliance one, which I know we all love tremendously because we just can't get enough paperwork. Anything that generative AI hopes to solve is to simplify or at least do less paperwork. Third-party risk management, security risk management, all of those kind of areas. Third-party risk management is a big one again in here. Again, that provenance thing that we're talking about from the data, well as data, model, and the software code libraries are all now directly correlated to the output of that system in a manner that was not present prior to AI, really, or at least not as much. Okay? All right. So how do we do this from a functional execution perspective with our clients? This is a fairly standard process, but it's still worth saying. First off, we have to have an assessment of the risk level. Like any good security thing, if all of us in the room who are doing the security one, the answer is not always to 11, right? It's not secure everything and break the bank. There's always a balance on that one. So what is a methodical approach in order to try to determine how sensitive is the system to either social implications, life safety, critical infrastructure, that kind of areas. And we do it with a fairly simple survey that creates a kind of 4-level risk matrix. From that risk tolerance perspective, we are then able to go and identify the pertinent security controls and implementations that match that risk level that is appropriate for that model. And of course, like any one of these things, this is a place from which to deviate, right? I mean, what's the quote? Forget it. Trying to do a good movie quote and I can't remember it offhand. But place from which, right? So you as you're doing a security control implementation, and you're talking to your organization about how to go solve this one. They might say, well, I'm really a little bit more worried about the database than I am about this other system, and you can always dial these things up or down as necessary based on the risk tolerance of whoever is responsible and accountable for the system itself. Once you've got it implemented and you've got it hardened, these systems, like any other good IT solution, they are dynamic in their own rights, and so continuous monitoring becomes critical to make sure that it's currently staying within the tolerance and bounds that you put it in. And then from that, right, so as a simple example, you can imagine, you're going in there, you have a system that's maybe like a tier 4, not critical, like downtime is SLA can be down for a couple days, but no one's, it's impactful, but it's not going to stop the primary business function. All right, that would create it as a low risk tolerance. Well, then what are the different kind of controls that are based off of that low risk tolerance under the different domains? So you get an example here, for example, on the data side, that you're going to do a data source inventory, but you're perhaps not going all the way down to a full SBOM, right, and a codified, locked and controlled mechanism for that. And then moving over to continuous monitoring by up to and including things like AI red teaming in order to make sure that it continues to be performant inside of the environment that you're executing it at. All right, so that's kind of the general background before we transition to my colleague Arnav, who's going to give a much more specific example with respect to Vertex AI. Any kind of initial questions? Sir? Is there going to be like very much a future casting thing? I personally, as a coder, would love to say yes. I've not seen it come out yet. There is some interesting work out of DEF CON, if you've seen what they did there for their, so DARPA did a challenge out of DEF CON where they put up a challenge against multiple different teams to basically, you get to have a container with it that has a AI connected system into it, and it'll be dropped into an environment, and it has to identify, detect, and secure without any human interaction into it. And they were able to find moderate success. The real subsequent part of that challenge will be, I think, next year, which is, I think 7 teams won $2 million each. Next year is like the grand challenge for a bigger kitty, if you will. But I think that's the goal. And I think things that we're seeing here, even with Google and MWise, right? Like the stuff that's going on with Chronicle, I think is going to be the closest approach that we're going to have with that kind of self-healing network or self-healing system approach. Oh, yes, ma'am.
Get you a mic. Sorry.
And I'll switch over to you after. Is that okay?
Yep.
You mentioned in the meta model with the data that you want to make sure that it's protected, but also free of bias, I believe you mentioned.
Yes.
How, with your customers and clients, are you actually measuring that, and how are you monitoring that? Because that's something that's been actually struggled with since way before the AI days. Like that's like a 10-plus-year-old problem in terms of machine learning and all this stuff. How does that actually kind of fit into this model in terms of like determining bias and risk in that data?
So a lot of my hat is on the cybersecurity side, which I find very convenient, right? Like I know that I only want the people who are intended to use the system to use the system. Everyone else is out. When we start talking about things like bias, ethics, policies, so these are societal norms and/or cultural norms of the organization. And there are, in fact, times where the system is intended to have a response, hopefully for a benevolent purpose, but not for something malicious, that would allow it to have a biased response for that function. So I think a lot of it goes into a combination that has to be done really, and it's a conversation about what is acceptable in your organization, what's acceptable for this specific use of this capability within that organization, and what are the dials that you want to turn on and off for that. And there's a lot of work, particularly in that control measure, for things like, is it LLM, the one we just saw upstairs?
Model Armor.
Model Armor. So for example, Model Armor has a suite of safety controls that they're building on top of Vertex AI that allows you to toggle those on and off, because it's not there's no free chicken here. Like there's no like magic, and these are all okay and these are all not, depending on the use case and the cultural norms. So it's I find that one's harder because there's always a line, and you have to navigate what that is very specific to the decision makers. Okay. So at this point in time, we'll have some time for more questions in a bit. I'm going to turn it over to my colleague Arnav, who's going to go deep dive into our work with Vertex.
Awesome. Thank you, David. One other aspect to the question you asked before I dive into that, the human element's also important, right? So David talked about like organizationally, culturally, but in terms of who's using it, how they're using it, and what's the intended function, there are some system level considerations, but there's a policy consideration as well. So we're going to be walking through a bunch of systems and a bunch of like toggles you can turn on and off to kind of help, but at the end of the day, you're going to have a policy that you have to implement. You're going to have training, you have resources for educating them on how to use it. So anyways, diving into diagrams now. So David talked a lot about how like the approach we typically take and we like to take with clients is focusing on the risk and dialing into which controls, which implementations matter in order to protect them and that system. What you see on the screen is more of a generic reference starting point, right? So what you're seeing is a lot of very traditional systems and components. Generally speaking, an AI application at the end of the day is still an application. You have infrastructure, you have data, you have your users, and then you have the model and the application itself. So starting on the left side, we're going to focus on some of the software development lifecycle. So you're going to have your typical ML ops or insert AI ML buzzword for how you deploy your model and how you determine the provenance of the model, right? So you're going to start with your packages. You're going to start with all of your model level code, which helps either train the model or is in the model itself. You're going to want to make sure you have a secure, restricted artifact registry. So Google's version is good. You can use a third-party one. You want to make sure that the transmission from there to your deployment pipeline is secured across the board, right? So all the trigger points, all the verification tools that you implement are passing, and you have all the green lights before you deploy in your production environment. On the left side, we show a couple of protections. One is the code scanner, one is the signature verification. Those are supported by less tool specific, but equally important bill of materials, as well as software supply chain inventory components. And those are important not only for maintaining a system of record over time for what goes into your model so you can trace it back, but also making sure that you have the right information to feed into some of the tracking and some of the lineage tools that David mentioned earlier. Now that you have your repository, you have a secure model, you're comfortable with what it does and you want to deploy in your environment, there's a lot of production network considerations that you have to take into account with regards to your model, right? So starting at the data domain, there's your data lake. That's the reference data that feeds your model. There's your model configuration, extremely important. If your configuration is tampered with, there's a higher than likely chance that your model is not going to do what you intend for it to do. And as we've all seen with ChatGPT and even Gemini, not to knock it at a Google conference, but there's been obviously a lot of trouble with some of the generative AI models and how they perform once they go live, right? So that model configuration is extremely important. And then specifically for generative AI models, there's a concept of a vector data, which pretty much functions similar to a data lake in the potential impact to your model. So we're gonna walk through a couple kind of more important configurations to make there. But there's also some new components. So there's your content filtering. That's taking a look, for example, Model Armor, at what's going into your model and making sure that you've filtered out malicious content, you've filtered out biased content. Again, it's kind of an ideal goal, and at the end of the day, you're probably not 100% of the time, but that's an important consideration. And then just across the entire stack, making sure that all of your entitlements and your access rights are in line with the business personas and the representative roles in enabling your model. To the right side, we highly recommend and typically see a replica environment, and that's used for all your ad sim and behavioral simulation tools that allow for you to discover other points of entry and other potential vulnerabilities on your system. And these are equally important, not just for general applications where they're typically deployed, but now with both AI red teaming as well as just general tools that have been created specifically for AI models to scan it and make sure that you've protected yourself against some of these maybe non-vulnerability based threats. So now let's talk about Google. So starting on the left side again with the pipeline itself, there's a number of tools that Google's come out with in the last 1 to 1. And they focused a lot on using tools they already have and making sure it's well integrated into that pipeline they've built through the Vertex AI platform. So starting with your scanner and signature tools, a big one here is Security Command Center. Security Command Center, as probably most of y'all know, is a very traditional kind of single pane of glass, get all your findings from your scans, and maybe draw those down over time based on priority and risk. With regards to Vertex AI in particular, they've implemented a number of these kind of toggles where if you purchase Security Command Center, you're able to get scans of your packages that feed into the model. If you have like a Colab or Vertex AI notebook, you can scan the code like a traditional SAST solution, or you could even scan the models themselves. So that's one of those Model Armor 2 come soon features, but that allows for you to look at aspects of the model like the underlying data, as well as how it's been trained. From there, there's pretty traditional pipeline deployment considerations. One very specific to Vertex AI that's very important is the use of trusted and verified containers. So Security Command Center allows you to have this capability where you scan containers, again, make sure, from an operating system, specifically for the container perspective, it's secured and there's nothing out of ordinary there. So they kind of go a step further and provide approved, or let's say Google approved containers that you can use within Vertex AI. So you can deploy your models, you can deploy something like a Llama off of Model Garden directly into a Vertex AI approved container, and you can, typical to your traditional golden images approach, you can feel comfortable and confident that generally you're covered against a number of potential vulnerabilities. From there, there's a lot more traditional Google Cloud hygiene from an access management standpoint and general data management standpoint. You can use Google native tools such as Secrets Manager, Key Management Service, as well as Cloud IAM to make sure you moderate access and you're securing all of your access points to APIs. One thing to call out with regards to both of those is a lot of these tools from Google are somewhat built in. A lot of them still require custom API calls, and one of the biggest considerations there is implementing an appropriate service perimeter architecture to make sure that your access to those APIs is moderated based on the perimeters and the configurations you apply there. So now moving on to the data and the model. With data lakes, the most commonly seen data lake technology we see in Google Cloud is BigQuery. And over the last, let's say, 1 to 1.5 years, there's been a lot of improvements in the security for BigQuery in particular, right? So there's row-based policies, there's column-based policies, there's also policy tags, and these allow for you to kind of more generally at scale automate the access management of individual pieces of data in BigQuery. There's residency considerations and something as well, but probably the most important is the use of data loss prevention tools to scan your data and make sure you're not feeding sensitive data into your model, right? You don't want, let's say, social security numbers that happen to be stored in one column for user information to potentially enter into responses on an external facing customer service chatbot, as an example. So again, a data lake is pretty vast and there's a lot of data. So the name of the game here is to use policies, use some level of automation to make sure you're securing your data at scale. Another big one is the model configuration. And I kind of mentioned this earlier, but the security of it is very, let's say, simple, but the implications of it is very vast, right? So when you have a model and you deploy it, there's your hyperparameters, there's all your tuning configurations. All of those sit and they feed your model and the behaviors of that model. So what you want to make sure you do is you lock down the configuration, and then you also, kind of as a side benefit, make sure you're consistently testing the performance of the model, right? So something we've done at Deloitte is we've built testing frameworks with models to make sure we're benchmarking their performance against the intended performance. So whether that's, let's say, a generative AI model and you want to feed in a bunch of prompts and maybe fuzz the input a bit to try different permutations of the inputs and make sure that the outputs perform as intended, or it be a machine learning model that predicts, I don't know, your fantasy football score on Sunday, and you want to make sure that the parameters that are feeding in don't drift and the outputs don't drift from where you originally intended for them to go. So for that one, you can keep as a secret, you can keep it in a highly secured data storage like a GCS bucket. But the name of the game there is locking it down and making sure that the access is only from the model itself, so you don't have a human tampering with it. A couple kind of net new ones for generative AI and, frankly, AI models. With vector databases, which is very much a new concept for generative AI models, Vertex AI has a built-in Vertex AI search capability, which they kind of deployed the vector database and the search application kind of in tandem when you use it. So the important configuration here is to make sure that you're using a private service connect between the database and the search application. And that's another toggle you put on when deploying it. And then the most important, the content filter safeguard, which, again, Google has a tool called Model Armor, about to go in GA, mostly API-based. But what it allows you to do within your application is make sure you have a level of filtering on the content that goes between your application or your model and what's in your database or your data store. Now, moving on to the last domain, the application domain, there's a lot of, let's say, very familiar aspects to this. Probably the biggest one is getting the foundations right. So for folks who are familiar with Google Cloud Secure Landing Zones or any of the Terraform scripts that have been distributed over the last 3 or 4 years, you need to make sure you start with the basics, right? You have a good resource management hierarchy. You have good hygiene in terms of your access management and entitlements and privileges. You're regularly scanning and monitoring what privileges and permissions you give to individuals, service accounts, and you're also setting up a secure network landing zone. A couple kind of newer considerations from a networking standpoint is the aforementioned service perimeters, but also probably more importantly, the use of private Google access that allows for a lot of your internal to Google Cloud communications to go over Google Wire rather than going over the internet and back around, as well as the use of private connectors. So some of these platform as a service capabilities, which Vertex AI being one of them, typically will communicate over non-segregated networks, fully encrypted. If you want, you can set up a private connection where it only goes through your VPC network. From there, depending on the type of model you're running, you want to make sure you're deploying the right operations monitoring agents. So if you're deploying in a custom container, Google Cloud has an operations agent that logs application and system level logs. Those are very important to either forward to a SIEM solution or some monitoring pane where you're able to look at what's happening at an application layer, a model layer, and a system layer, and use those logs to set up a chain of events. Let's say if you find that a model is compromised. And then also if you deploy a model in Vertex specifically, leveraging their Vertex AI agents built on a very similar platform architecture, but it allows you to track some additional levels of logging and monitoring. Lastly, the aforementioned behavioral adversarial simulation tools are extremely important to set up an additional testing range to make sure that you identify potential points of entry. There's numerous tools out there. It's not just a tool approach. It's probably red teaming plus tool plus running purple teaming exercises approach. So just constantly testing the integrity from a security standpoint of your infrastructure, your model, and your application. Now, for just some visibility into kind of like how does this actually show up in the real world, we ran this for a biotechnology organization. The aforementioned framework that David mentioned had over 120 GenAI controls for that risk level for the system. And Vertex, pretty much out of the box with a few clicks, enabled almost 53, right? So there's real scalability and acceleration from using a platform like Vertex AI. I know we're all at a Google conference, and obviously like tools, we like what they're providing on the market, but a number of these are, at least from where we stand, very competitive in the market. They help you get a good starting point for a number of these considerations that we talked about earlier, but it's not the full story, right? So there's a whole nother set of controls, there's a whole nother set of considerations that require you to really inspect your stack and identify people, process, technology solutions to ensure that you're having 360-degree protection for your models. So with that, thank you for your time. Are there any questions for anything David or I covered here today, or just general topics that you want to talk about? Cool.
All right.
Thank you.
Perfect.